Hello students, and welcome to topic 3 of alternative and renewable energy sources. This topic we will be covering solar energy fundamentals. This topic's lecture is broken into 3 parts. In each part we will do an activity. The activity is recorded and you are to work the activity along with the recording. We begin with some important terminology. Solar radiation is a general term for the electromagnetic radiation emitted by the sun. You can see that the incoming solar radiation is either reflected or absorbed by the Earth. Approximately 6% is reflected by the atmosphere, 20% is reflected by the clouds, and 4% is reflected by the surface of the Earth. Approximately 51% is absorbed by the surface of the Earth. Approximately 19% is absorbed by the atmosphere. The important point to be stressed here is that not all of the solar radiation is absorbed by the Earth. Direct beam solar radiation reaches the Earth's surface without being diffused or reflected. If we go outside on a bright sunny day, the sun is very visible and sunlight goes directly to the Earth. That's what we call direct beam solar radiation. On a very cloudy day, we cannot even see the sun. However, the sky is relatively bright because the sunlight is diffused over the entire sky. Usually we have a combination of direct beam and diffuse radiation. Albedo is radiation that is reflected from a surface. There are some special cases in which reflected solar radiation can play a very important part. Total solar radiation, which is a combination of direct beam, diffuse, and reflected solar radiation. Solar irradiance is the rate at which the radiant energy is incident upon a surface per unit of surface. Solar irradiation is the amount of solar radiation measured over time. It is a measure of the total amount of energy per meter squared or per foot squared. Solar insolation is the amount of direct and diffuse sunlight radiation as watts per square meter over a period of time, usually a day. We will be using solar insolation to estimate solar photovoltaic and solar thermal production, but we will be relating it to peak sun hours. The map of the United States shows the amount of sunlight energy per day at different locations. It is important to note that when the solar radiation is measured at different locations, the surface upon which the sunlight shines is always tilted up towards the sun at an angle from the horizontal equal to the latitude at that location. This is a map indicating the solar radiation per day in South America. This shows almost the entire world and its solar radiation. Here we see the solar radiation in China. This is another view of the solar radiation on the United States for the month of August. As the image shows, the solar constant is a measure of the solar radiation on a surface outside the Earth's atmosphere perpendicular to the rays of the sun. The value of the solar constant on an annual average is 1,367 watts per meter squared. Here we see an overall view of the solar radiation incident upon the Earth, indicating a portion being reflected from the Earth and a portion being emitted from the Earth. This gives a surface temperature of the sun to be about 5,777 degrees Kelvin. We can use this for a theoretical calculation of the solar constant. The diameter of the sun is given to be 1.39 times 10 to the 9th meters, or about 863,706 miles. The Earth's diameter is about 7,900 miles. The distance from the center of the Earth to the Sun is given to be about 1.5 times 10 to the 11th meters, or about 93,205,679 miles. This is a heat transfer equation for solar radiation, in which E sub b is a symbol for blackbody radiation. It is equal to the Stefan-Boltzmann constant times the fourth power of the absolute temperature of the surface. This equation includes the surface area into the equation. We calculate the solar constant using the surface area of the Sun divided by the surface area of a sphere centered on the Sun and going through the center of the Earth, multiplied by the Stefan-Boltzmann constant and an estimated fourth power of the surface temperature of the Sun. This calculated value is 1,356 watts per meter squared, very close to the accepted value of 1,367 watts per meter squared. The actual numbers used to calculate solar constant are included here. The emissivity of a material is the relative ability of a surface to emit energy by radiation. It is a ratio of the energy emitted by a particular surface relative to a black body. All bodies emit radiation by virtue of their temperature. However, not all surfaces emit radiation exactly the same. The properties of the surface also control the amount of radiation. We all have experienced the fact that a car painted black absorbs more solar energy and is hotter than a car painted white. This example is somewhat close to a body's ability to emit radiation. It is a function of temperature of the body and the characteristics of the surface. Absorptivity is a fraction of the incident radiation that is absorbed by a body. Reflectivity is a fraction of the incident radiation that is reflected by the surface of a body, and transmissivity is a fraction of the incident radiation transmitted through the surface of a body. The summation of all three fractions must be equal to 1. Air mass is the optical path length of solar radiation through the Earth's atmosphere. Air mass is a terminology that is used in the solar PV industry. All solar cells or modules must be rated under the same conditions, one of those being the amount of atmosphere the solar radiation must go through. This is a solar radiation outside the Earth's atmosphere as compared to an air mass equal to 1.5. Same graph, but in an expanded view. This is somewhat of a similar view of the solar radiation at the top of the atmosphere and at sea level, but also indicates what is ultraviolet, what is visible, and what is infrared. The seasons of the Earth are as a result of the tilt of the Earth's axis. The Earth is tilted at approximately 23.5 degrees. Here we see a view of the different seasons. In the winter, the northern hemisphere is tilted away from the sun, which decreases the amount of solar radiation received by the Earth per square foot. In the summertime, the Earth is tilted towards the sun in the northern hemisphere, allowing for more solar radiation per square foot. Solstice is an astronomical event that happens twice each year when the Earth is either tilted towards or away from the sun. Here we see summer solstice. Here we see winter solstice. Equinox, as shown here, occurs twice each year, once in the spring and once in the fall. At equinox, the Earth's equator is facing directly toward the sun. The incident angle is the angle between the sun's rays and a line perpendicular to a surface. Latitude is the angular measure in degrees from 0 at the equator to 90 north or south of the North Pole or South Pole. This is a visual representation of the latitude. Solar azimuth angle is defined as the angle between the line of an observer to the sun projected onto the ground and south. An easier description is the angle of the sun with respect to south. A visual representation of the solar azimuth angle is given here. Solar radiation incident upon a surface is a function of the solar time, the latitude, the air mass, and any shading that might exist. Solar elevation or altitude angle is simply the angle that the sun makes with respect to the horizon. This is a visual representation of solar elevation or solar altitude. If we were to stand at a location and had a plastic surface to look through, and were able to plot the path of the sun from winter solstice to summer solstice, we would then have a sun path diagram represented at a particular latitude. If we now unroll that plastic sheet, it would be flat as seen here. This is an expanded view of the rolled out plastic sheet. If there are any questions, please post them on the eLearn Help discussion.